Uh, Hello guys. Today we're going to be looking at symmetry of roots of cubic equations. And for quadratic equations, you can go back and watch my videos. Please remember to like and subscribe. Now, let's go. The general form of a cubic equation is a x cubed plus b x squared plus cx plus d equals 0. Now, normally the highest power of the variable here, which is x cubed, normally tell us the amount of roots that this equation has. And by nature, a cubic equation will suggest that it has 3 roots. So we're saying that our roots, let the roots be, so let roots be alpha, beta, and gamma. All right. So we're looking at 3 possible roots here. And remember, we said once we have roots, we can actually come up with our factors. So my factors would be x minus alpha, x minus beta, and x minus gamma equals 0. All right, so those are the factors. And when you multiply all of them, it actually produces the equation. Now let us try to expand this to see if we can actually get what the equation is. We can start by looking at any 2 possible brackets. Let us say we decide to go with the first 2 brackets. This is what I'm going to have. So I'm still going to have x minus gamma in this bracket here. This is equal to 0. So we expand it just like how we expand a normal bracket. Each thing in the first bracket will multiply each thing in the second bracket, or each term. So this is going to give me now x times x, that is x squared, x times negative beta, so that's minus beta x, negative alpha times x, that's minus alpha x, and negative alpha times negative beta would give me plus alpha beta. Cool. Now let us expand this further now. Now if I try to multiply these 2 brackets now, I'm gonna have x squared and I'm gonna multiply by everything in the second bracket. So this is what I'm gonna have. I'm gonna have x squared times x, which is gonna give me x cubed, x squared times negative gamma, which is gonna give me minus gamma x squared, minus beta x times x. So I'm gonna have minus beta x squared, minus beta times minus gamma. I'm going to have a positive beta gamma x. Now minus beta, well, minus alpha x times x is going to give me minus alpha x squared, minus alpha x times minus gamma is going to give me positive alpha gamma x. All right, then we move to the very last term in the first bracket. So we have alpha beta times x. That is going to give me plus alpha beta x. Then we're going to have alpha beta times negative gamma, which is going to give me minus alpha beta gamma. And all this is equal to 0. Our task is now to group the like terms, and we're going to give it some order. So since we have alpha beta gamma in the Greek alphabet, let us try to keep it in that order. So this implies now that this becomes x cubed. All right, looking for my like terms, I'm going to have minus alpha x squared minus beta x squared minus gamma x squared. So I'm finished with the x squared terms. Let us now look at the x terms. So I could probably go plus alpha beta x plus alpha gamma x plus beta gamma x minus the constant, which is alpha beta gamma, is equal to 0. All right. Now we want to factor out the coefficient so we can clearly see the terms individually. So here I could go x cubed. Minus sign is common for the x squared term, so I could take out the minus sign. I could also take out the x squared. So in brackets, I would have alpha plus beta plus gamma. All right, looking at x terms, notice the x is common. All the terms are positive, so I could factor out the x here. So I have alpha beta plus alpha gamma plus beta gamma minus the product of the roots here, which is alpha beta gamma equal 0. So just as we mentioned that, here are some important points to take now. Now notice what we have here is what we call the sum of the roots. Here we have the sum of product of roots pairwise because they are in pairs and we're adding them. And over here we have the product of the roots. All right. Now to effectively compare this, let us go back to the general form of the equation. We told you that the general form of a cubic equation was ax cubed plus bx squared plus cx plus d equals 0. And to get this comparison effectively, I'm going to have to make the coefficient of the x cubed 1, just like how it is in the equation up here in green. All right. So let's go. Now let us divide this entire system by a. What is going to happen? I'm going to have x cubed plus b over a x squared plus c over a x plus d over a equals 0. Because if I divide 0 by a, I'm still going to end up with 0. Now let us do our comparison. Look at the coefficient of x squared. We have negative the sum of the roots, and down here we have b over a. So let me just draw some lines here. So we are comparing. Look at that. Look at the coefficient of x, and look at that down here, and look at the constant up here, and look at the constant down there. So let us go now and make this comparison. All right. So this is what we can say. Yeah? Let me just go down and get some space here. We realize that the sum of the roots, which is negative of alpha plus beta plus gamma, is equal to b over a, which means we can say that alpha plus beta plus gamma is equal to negative b over a. Pairwise, which is the coefficient of x, the sum pairwise, alpha beta plus alpha gamma plus beta gamma would be equal to the coefficient down here, which is c over a. And the product of the roots, which is alpha, beta, gamma, and bear in mind that this was negative, would be equal to d over a. So I could simply say that alpha, beta, gamma is equal to negative d over a. All right. So we have drawn a comparison now between the coefficients and the roots themselves. So let us say that this question was posed here. Find the equation with roots negative 1, 2, and 3. The first thing we're going to do is to go to our general equation, which we say is going to be x cubed minus the sum of roots times x squared plus we have the sum of product pairwise, and all of this multiplied x minus the product is equal to 0. All right. So what do I mean by that? All right, let's go. The roots here are negative 1, 2, and 3. So it's going to become x cubed minus, big bracket here for that, negative 1 plus 2 plus 3 times x squared plus, all right, and we can use some small brackets here, the sum of the product pairwise. So we can have negative 1 times 2 plus negative 1 times 3 plus 2 times 3, and all this is going to multiply my x. So all this is the coefficient of my x minus the product of my roots. So I have negative 1, 2, 3, and all this is equal to 0. So this is going to break down to give me x cubed minus 4x squared plus x plus 6 equals 0.